Hello and welcome everyone to the March edition of the HbbTV webinar series on a sunny afternoon actually here in Germany where I'm based. My two presenters are based somewhere else and still this is international, and as is DVB and HbbTV, a very international operation and association. We're going to hear all about DVB and HbbTV technologies in TV systems today. In the next 45 minutes, we have two presenters, and then after the presentations, we have 15 minutes of Q&A as usual. So this is live, which means that you can submit your questions anytime during the presentations. Please do so. You're very much welcome to submit your questions and use the chat box. The question function is on the right-hand corner of your screen. And I'm honored and pleased and very excited to welcome our two presenters today. First, that's Peter Lanigan, Senior Manager Standardization at TP Vision. For those of you who don't know TP Vision, it's the manufacturer of Philips branded TV sets across Europe and in other markets. As the second presenter today, we have Peter MacAvock. He's Head of Delivery Platforms and Services at EBU Technology and Technology Development, and he's also the DVB Chairman. Welcome and thanks for taking the time to be with us today. As usual, before we get started, the disclaimer: the presentations represent the views of the presenter and the companies he represents, and not necessarily the views of the HbbTV Association. So it's over to you, Peter Lanigan, now for the first part of the presentation.
Hi, good afternoon. I'll just show my slides.
Yes, okay. Thank you.
So thank you. My name indeed is Peter Lanigan. I work for TP Vision, and I'm also the chair of the DVB commercial module group that is responsible for DVB-I. So I'm going to give you an overview today of DVB-I, of DVB content delivery technologies, but I'm going to particularly focus on DVB-I and also a little bit on DVB targeted advertising. So DVB has provided the fundamental standards used for delivering digital TV services for more than 2 decades, and this includes DVB TCNS for transmission over terrestrial cable and satellite networks, of course, DVB-SI for signaling and metadata, and DVB-ABC for audio and video coding. And more recently, DVB has also supported IP technologies with standards such as DVB-Dash. And HbbTV indeed is built on these technologies, of course. Well, I guess people here are quite familiar with them. This presentation is going to look primarily at newer DVB standards and how they also relate to this existing ecosystem. I'm going to focus mostly on DVB-I, which looks at IP signaling and delivery of DVB services. I'll also mention DVB targeted advertising, and I'll say a little bit about future work as well. And of course, please do submit questions in the chat as we go along. So firstly, what is DVB-I? Well, as you know, DVB already has DVB-T, C and S, and indeed T2 and C2 and S2 for delivery over terrestrial cable and satellite systems. And DVB-I is a new addition to that suite of technologies, where the I stands for Internet. DVB-I delivers services over the Internet to devices with broadband access, and this means over the top, but it also means managed networks with operator support. The user experience of DVB-I can be similar to DVB-T, and S, and I'll explain what that means in more detail as we go through. And I'll also explain what I mean when I say DVB-I can be used in combination with DVB-T, and S. And that's an important point because DVB-I is not just an alternative to T, and S, it's also intended to supplement and build on them. And all devices with internet access are in scope, not just TVs and set-top boxes. So why is DVB-I needed? Well, in the last 2 decades, I suppose, the internet has transformed how we access television. We've moved from basic video on websites through new kinds of service like catch-up TV. We've seen the development of these vast global video on-demand services, which have become not just ways to deliver content, but also major original content producers. And we've seen the kind of, and we've seen the traditional broadcasters, existing broadcasters, make use of the internet to deliver their services and to extend their services. The example here being Sky and Now TV, but there are many examples across Europe and the world. And we've seen the development of completely new kinds of service, such as Facebook Live and YouTube, which simply wouldn't have been possible in the old days of broadcast infrastructure. So the internet has brought many new types of service, and this has been a very positive thing for users. And if we think a little bit about how those services are being deployed, because deployments of services in the end is what DVB is about, and distribution of services, well, these services have been deployed as apps, where an app might be something you install on your smartphone or your PC or your tablet, or it might also be a web page, some HTML and JavaScript. But in the end, it's a piece of software that runs on your computer, or on your phone or whatever. It's specific to that service, and you use it to access that service. And in some ways, this is a little bit like the old vertical market set-top box that you might use to access an operator's services. Now, apps have been enabled a lot of creative work and a lot of new kinds of service, and have been really a great thing for innovation, and they've allowed these services to develop outside the normal processes, the traditional processes of the media industry. But they also come with some disadvantages compared to a fully standardized system where you have maybe one type of receiver that can access all the content, which is what we may be used to in the DVB world. From the point of view of users, content is segregated into independent apps, and not all apps are available on all platforms. For users, it's maybe harder to find content in this case. For broadcasters and service providers, they have to provide and maintain apps for multiple platforms, which can be a major burden on them. They have the question of how to get their app noticed in this new world where there's many different types of apps available for in app stores or installed even on users' devices. There's also the question of how to combine with and extend existing broadcast services. After all, a broadcaster doesn't want to throw away everything they already have, but they do maybe want to extend it and not only reach new users, but also offer new kinds of service in combination with their broadcast services. And for manufacturers, such as my company, we have many apps to support and to certify on our products, which is a major burden. It's hard for us to provide a consistent user experience, and we end up providing multiple solutions to the same problem in our products, which is expensive and complex for us, but doesn't actually provide any real benefit to the user. So how does DVB-I help with this? Well, DVB-I intends to do for IP services what DVB TC&S do for broadcast, and the associated specifications. Services are signaled and distributed in a standardized manner, so that you don't need a specific app for each service. So a single app or a single client can receive all DVB-I services. A receiver is able with DVB-I to present an integrated list of services and contents, including DVB-I and broadcast services. Users don't have to know or care whether a service arrives via broadcast or IP. Broadcasters can deploy a service once to a wide range of devices, and broadcasters can also create a single offering, including both broadcast and IP services. Manufacturers can make a single consistent user experience for DVB-I and the broadcast services again. So I'm going to look in a little bit more depth at what I mean by all of these things now, and how DVB-I achieves those. As I'm the chair of the DVB commercial module group looking at DVB-I, I decided to give you an overview of the commercial requirements we wrote for DVB-I. These were then taken by the DVB technical module to write the final DVB-I technical standard. But if we go through the commercial requirements, you get an idea of what's possible with DVB-I. So in terms of the areas of applicability, the scope the DVB-I intends to address, we're addressing any device with an internet connection and a media player. It doesn't have to be a TV or a set-top box. It can be a phone, a tablet, a laptop. It can be any kind of device. DVB-I specifically will work when you don't have a DVB tuner, but just an IP connection. But it will also support the case where you do have a DVB tuner as well as an IP connection, and have interesting ways to combine services from the two sources and integrate services from the two sources. DVB-I works over broadband or Wi-Fi or mobile networks or any kind of IP network which has enough bandwidth to deliver media services. DVB-I can work over the top or with network operator support. And as I say, DVB-I services can be received with a standard receiver, so you can make one receiver that can receive all DVB-I services. But of course, we don't restrict it to that. You could also make a downloadable application for any kind of device that receives DVB-I services as well. So what kinds of services does DVB-I support? Well, we support, of course, broadcast-like services, so linear TV and free and pay TV, and of course, all the things you'd expect associated with that from a DVB standard. So we support accessibility features like subtitles and alternative audio tracks. You can even associate applications with DVB-I services. So you can have an HbbTV application, for example, associated with a DVB-I service in the same way you can for broadcast. And we support all the features like parental control that you would expect in a broadcast regulated service. We also support services specific to IP, such as video on demand and personalization. And you can even make things like scheduled VOD services. So this is where you make a playlist of VOD assets, but you present that to the user in the form of a linear TV service. And of course, that's a good target for personalization. As I said, DVB-I service offerings can be standalone or they can be integrated with broadcast. And I'll look in a bit more depth what I mean by that a bit later. In terms of the user experience, well, DVB writes technical specifications, and in principle, we don't really say anything about the user experience, but we can enable or prevent various aspects of the user experience. And one of the things we wanted to enable with DVB-I was a user experience that was similar to DVB-TCNS. What we mean by that is that navigation through DVB-I services is possible using a channel list and a program guide, much as you would a conventional broadcast service. And it's possible to do that with DVB-I. And you can also integrate IP services and broadcast services into a single channel list and program guide and present it to the user in that way. That's not the only aspect we had to consider. It's also important. There are some performance characteristics that you also need to consider in making something that's equivalent to broadcast. So, for example, the zapping times between linear channels, linear DVB-I channels should be similar to that for broadcast channels. So from the user's point of view, they're getting the same experience. And finally, a very important point that's covered in the commercial requirements is the issue of service discovery and trust. Now, there's a lot of questions here which go a little bit beyond a technical specification, questions like who provides a service lists. The service list is kind of the fundamental currency of DVB-I. In the end, it's the service and the service lists. There's a question of how a receiver finds relevant services, given that many thousands of channels might technically be available to a user. I mean, if you compare service discovery on the internet with service discovery, for example, from a terrestrial broadcast system, with a terrestrial broadcast system, you connect the receiver to an antenna, and you do an RF scan, and the results of that scan are what you present to the user in the channel list. That doesn't really work on the internet, where there may be many thousands of channels and maybe many thousands even of lists of channels available to the user. So there's a question of how you find something relevant to present to the user. And there's a question of how legal and trusted services are identified as well. In general, we trust that broadcast services are regulated and comply with local laws and have, in terms of not only copyright, but taste and decency and child protection and so on. How do we try and achieve similar things online? Now, these are not only technical, but they're also commercial issues. And DVB-I can't solve these by itself, but we provide in the specification the technical means for these problems to be solved. We now see that as the DVB-I specification is being picked up in various places across Europe and beyond, that people are looking at how they'll use the facilities of DVB-I to solve these problems in their own environments. And I'll mention this a little bit more as I go through as well. So in terms of the DVB-I specifications, those were the commercial requirements. These were then taken by the DVB technical module, who wrote a technical specification. Now, the main spec we refer to when we talk about DVB-I is this specification, the DVB-I service discovery and program metadata specification. And this covers signaling and discovery of DVB-I services and content. This was first published in November 2019, and there was a revision in July last year. And it's available as an ETSI spec, it's ETSI TS 103770. This is not a standalone specification, though it builds on other DVB-I, on other DVB specifications. Most notably, it builds on DVB-, which is used for the delivery of services online. This is a profile of MPEG- targeting DVB services. The last update to this added low latency support, which is very important for DVB-I. This reduces the delay between, if you like, considering a live service between the camera and the user, potentially to a few seconds. And this is very important for supporting linear and live services. Of course, DVB- is also one of the building blocks of HbbTV. And this is an important enabler, I think, for DVB-I and HbbTV to work together. Another important spec DVB-I can make use of is a new specification called DVB Adaptive Bitrate Multicast. This enables the efficient delivery at large scale of linear AV services over an operator network to large numbers of users. And it does this by allowing an operator to use multicast within their network. So they only have to carry a service, a linear service once, rather than carrying it once per user. This is potentially a huge optimization. And an important thing about this spec is that it's potentially transparent, or it can be used in modes where it's transparent to receivers. So an existing MPEG-dash receiver, a television or a set-top box or a phone or whatever, doesn't have to be aware that this is even happening. And the multicast is converted to unicast at either near the edge of the operator's network or even in the home gateway. The first version of this spec was published late last year, and there's some work ongoing to expand that a bit at the moment. And of course, DVB-I builds on other DVB specifications, such as the DVB video and audio coding format spec. And this means that as with broadcast, you can use all the audio and video formats to support everything from standard definition, high definition, up to UHD, high dynamic range, with dynamic metadata services. You can support next generation audio. And of course, you can support accessibility features like subtitles and multiple audio tracks. This is all possible with DVB-I. Just to look quickly at how the protocol stack looks, for those who like such things. The IP networks is at the bottom with DVB-I and a pure IP deployment. The DVB-I service discovery is how you find the services. DVB- is used for service delivery, or DVB adaptive bitrate multicast. DVB-ABC is used for the source coding of the services. And a receiver application brings it all together, which can be a native application or a downloaded application, presents them to the user. In the hybrid case, a hybrid meaning that a service offering that incorporates both IP and broadcast services, we add here on the right a broadcast terrestrial cable or satellite network with delivery using MPEG-2 and signaling using DVB-SI. And this is all brought together again by a receiver application that can render these in a consistent manner and render them together to the user. And a way that that's enabled is by the fact that the DVB-I service lists are able to refer to broadcast services, but also the DVB-SI is able to refer to DVB-I, is able to refer to a DVB-I service list and instruct a receiver to get the DVB-I service list. And to dive slightly deeper into that, this shows the kind of data structures that are used within the DVB-I specification. And this gives an idea, this is as far as I'm going to go technically, but it gives you a good idea of what's possible. The first step is this green step, the service list discovery. This is where a receiver finds out which lists of services are available to it. Now, this could be done at the most simple way, that is the URL for a service list. A list of services is hard-coded in a receiver. But perhaps more likely, for a more generic receiver, the receiver will query something in the network to find out what service lists are available to it. The user will then select service lists perhaps relevant to their country or to the operator that they're using, or potentially their interest as well. Now, the question, so DVB-I is a concept of a service list registry, where which a device can query to get a list of service lists available to it. This could be provided in various ways. One option is that even the DVB could provide a registry of available service lists, but it might also be done on a country-by-country basis, where someone wants to take responsibility for that in a particular country. Or it could also be that manufacturers in the end keep lists of the service lists that their receivers can connect to. There are various possibilities here, and again, this is one of the things that's being considered now by those who are looking to use DVB-I. Once a receiver has decided on a service list, it can acquire that list, and that's the step shown here in yellow. And a service list is intended to be indeed the list of services that is shown to the user in the channel list on the TV. The next level down beyond that is the content metadata. So this is the equivalent of the EIT data on broadcast. This is the information you use to populate the content guide, the electronic program guide, with the schedule and the programs that are available. This can include linear content, but also video on demand content. And the final step here, which is very important in the flexibility of DVB-I, is the media representations. For any service or any item of content, there will be at least one media representation, and this tells the receiver how to get the content. Now this might be a URL to a DVB dash stream. It can also be a reference to a broadcast service. So a DVB-I service list can include both broadcast services and IP services. But it's also possible for a service or content item to have more than one media representation. So you can have a service which is available via both IP and broadcast, and a receiver can then make an intelligent decision on which version of the service it will acquire. You could have a case, for example, where on broadcast there's only a standard definition version available, but on IP there's a high definition version, and the receiver might choose to take the high definition version. It's even possible to do this on a timed basis. So you could have an IP version of a particular program, perhaps supporting UHD or HDR, which supports a use case we see some broadcasters making use of now. So I think that gives a quick overview of the DVB-I spec. I wanted to mention that DVB is doing a bit more with DVB-I than it's maybe done in the past, and in fact is looking to do this with all its work, all its new specifications now. We want to go a little bit beyond just publishing a technical spec and throwing that over to the industry. We want to help with the industry adopting the specification. And we do this with an activity we've called V&V, validation and verification. And the end result of this for DVB-I is that we've also made an open source DVB-I reference client, which you can download from the URL there, or you can easily find on the DVB website. This is an open source client that you can take and you can play with. The front end is written in HTML and JavaScript. It's really a DVB-I client. It will acquire, it'll allow you to choose between service lists. It will show you the service lists. It will allow you to zap between available channels, open a program guide, and so on. And it will run in any web browser on your PC or on a mobile device. And it can even be used as an HbbTV application, so you can run it on a television. Also available are examples of service lists and content guide metadata and validators for content and metadata. Which we hope will allow people to quickly start to use the specification, but also do so in a way that's interoperable and avoiding problems in the field. Another important activity DVB's done to support the deployment of DVB-I is some joint work with a -IF, where we extended the FFmpeg open source video encoder or media encoders to support low latency dash. So you can also provide real low latency dash services using FFmpeg now. Okay, so that's DVB-I. I want to quickly mention another important specification, which is a new specification DVB launched last year on targeted advertising. Now, the first version of this spec has supported the dynamic substitution of adverts in linear broadcast TV. So this is targeting receivers which receive linear TV via broadcast, but also have an IP connection. And they allow for content, so usually adverts, to be substituted. Content on the broadcast to be substituted with content via IP. And this can be done on a targeted basis, so you can show users watching a broadcast service advertisements targeted towards that user or towards that region, or targeted in some way. This is an important way to improve monetization for broadcasters. There's two parts to this specification. These are these ETSI specs you can see here, 103.752. The first one is covering the signaling that's used towards the receiver from the service provider, and the second looks at interfacing to advert decisioning services, which decide what adverts to show a user, and also on the preparation of media so that a receiver can seamlessly splice between the broadcast and IP advert. And these specifications are important also for HbbTV because they're used as the basis of HbbTV's targeted advertising solution. Now, this specification currently targets linear broadcast services, but we're now starting some work to also support DVB-I services with targeted advertising. In fact, we've recently approved commercial requirements for doing this. What we're thinking of here is the same user experience as for linear TV, so the user sees targeted or substituted advertisements. But DVB-I offers new and potentially more efficient, or at least different ways to implement that. It's possible to do all the ad insertion or substitution server side and just deliver a single stream to the end user. But you may still want to keep certain aspects of the previous system, where, for example, you do a reporting of which adverts are being consumed from the end device, because that's the most reliable place to do it in the end. So this is technical work is now starting on this in DVB. And those who are interested in this, maybe now will be a good time to get involved in the work in DVB if you're not doing so already. One other piece of work I wanted to mention that's ongoing in DVB regarding DVB-I is looking at DVB-I for 5G networks. Now, as I said, DVB-I is usable on any IP network, and in fact, we've always had commercial mobile networks. What this activity is looking at is actually making sure we support 5G networks in an optimal way, that we integrate with the special features that are present or are being specified for 5G for media distribution. There's three main use cases we're working on. This is DVB-I services delivered over 5G unicast, and this is making use of special features of 5G for delivering the service. We're also looking at supporting DVB-I services over 5G broadcast, and this is to support 5G when used in a broadcast mode, and also DVB-I services over 5G for fixed wireless access. And this is where 5G is used as a way of providing the user with a broadband connection. So this is ongoing work. The commercial requirements are now being finished, and technical work should start on this shortly. Again, this is another good opportunity for the people maybe to get involved with the DVB-I. Okay, I'm almost out of time. So just to summarize a few conclusions from this, DVB-I enables the delivery of DVB services over the internet, supplementing DVB TCNS and also providing a path to 5G. DVB targeted advertising gives broadcasters additional options to monetize their services. In terms of services, they can reach more users on more devices, and they can also reach users without traditional broadcast reception. Users can access more services, and they don't need to know or care whether a service reaches them via DVB TCNS. And DVB is supporting its members with new deployment options. We're bringing opportunities to support new parts of the industry, and we're extending DVB's relevance outside the traditional broadcast domain, which is also potentially interesting for users of DVB specs such as HbbTV. DVB-I and DVB-TA are available now. The specifications are available. There's also things you can play with and try out in terms of reference applications. And of course, these are not specifications and standards that will stand still. So I'd encourage people who are interested to join DVB if you're not already members, and contribute and help shape the future direction of these important standards. Okay, thank you very much.
Thank you, Peter, for this very interesting presentation with lots of aspects involved, where I would say these do give room for questions and discussions. And I would like to use this opportunity again to make you aware of the fact that you can submit your questions through the questions column in the chat box. Please do so. A lot of people have already submitted their questions. This is no surprise, because forgot to mention that 266 people have registered today to watch this webinar live. That is one of the highest audiences we've had so far for the HbbTV webinar series. So thanks for your great interest, and please do keep the questions coming in. And TP Vision is of course based in Brussels in Belgium. As I said earlier on, this is a very international webinar, and we now go over to EBU, which has its headquarters in Switzerland, in Geneva, to Peter MacAvock, who's going to start with his presentation. Thank you.
Good afternoon, everybody, and I hope that we all find you well. I am Peter MacAvock, as we said, and I am from the European Broadcasting Union. I have two other roles, however, which are of relevance to this particular webinar. One of them is the role of HbbTV Requirements Group co-chair, and the other one is as chairman of the DVB Project. And we'll get to have a look a little bit more about the relationship between the two organizations in a second. So the first thing I'd like to do is to cover some of the issues that are rather similar between the two organizations. So I suppose it's fair to say that HbbTV itself rose from a grouping of companies that failed to build on the DVB's hybrid television solution, MHP, way back in the day, and therefore chose to take their specification work outside of the DVB project. It's okay. So they did that. But of course, what we'll find is that there are quite a lot of similar organizations involved. So as it happens, it's not by chance, but because there's a certain number of us are involved in both organizations, but both HbbTV and the DVB project are Swiss-based associations. They're both not-for-profit, and they're both based at my employer's headquarters, the European Broadcasting Union, which has a habit of fostering such organizations that it believes are central to the public service media technology development roadmaps. So of course, there are other similarities as well. There are similar members in HbbTV and DVB, although as we see there's a bit of subtlety. Each member pays a similar membership fee. DVB happens to have about 150 members, and HbbTV, as at my last count yesterday, was at 77 members. Now it's fair to say that almost all HbbTV members are DVB members, but the same is not true in the other direction, of course. And there are many common personalities. As I mentioned, I co-chair the HbbTV requirements group, but I'm also the DVB chairman. And the HbbTV vice chair, who works with Peter Lanigan, chairs the DVB's technical module. So we frequently find ourselves in the somewhat bizarre situation of writing each other liaison statements. In fact, sometimes I write liaison statements to myself, which sounds a bit odd. Anyway, it works. And for the large part, these common personalities ensure that there's some alignment in terms of roadmaps and that there is a good working relationship between the two organizations. And the reason why there are two organizations is that there are some key differences between the DVB project and HbbTV. DVB has a wider scope than HbbTV. It includes paid television, it includes vertical market, it includes set-top boxes. These are not the primary focus of the HbbTV Association and its work. Its focus is rather on retail, horizontal markets, and with a particular focus on TV sets. In addition, the HbbTV Association has a process of developing its own test suites for the purposes of aiding implementers to implement its work, which is sort of normal. But rather than having somebody else do it, HbbTV has a policy of developing its own solutions. So it's a key activity in HbbTV that consumes the majority of the annual budget. You can work out what all the numbers are, but the bottom line is HbbTV spends a lot of money on its test suite to ensure that it is a high quality test suite to aid the implementation of interoperable solutions. So of course DVB has moved an awful lot since it was first founded way back in 1994, and it's fair to say that if its first mission was the standardization of technical solutions for the purposes of ensuring the transition from analog to digital television, its primary focus is now very different. And we're focused on managing the transition to hybrid and indeed possibly all internet-based television services, television and other media services, targeting not just TV sets, although that is the primary focus for now, and set-top boxes, but any kind of device that carries a media service. So I think it's fair to say that as that role has evolved, and we've seen evidence from Peter Lanigan of the various different activities that we're involved in, we move further up the OC stack, and that entails a greater concentration on aids to the implementers for implementing solutions. So Peter pointed to validation and verification, a core proposition of the HbbTV Association, now becoming a core proposition within the DVB project, but it's a much lighter touch approach, because validation and verification for the wider scope that DVB has isn't just focused on the provision of a test suite for a given specification. So in summary, the organizations are rather similar in terms of membership, in terms of how they were established, and in terms of the way they're established, but they have a different scope. And that scope is reflected in the focus within the different organizations. But it's complementary. So as an example, what I wanted to do was some work that was done in the group that I co-chair in HbbTV some time ago, which was to try and turn HbbTV from a reactionary group into a more proactive organization in managing its own proposition. And so what we've done is we've instilled within HbbTV now a life cycle for the development of a specification. And it starts actually 36 months away from the rollout of HbbTV product based on a specification with a set of requirements. After those requirements, there is the development of a technical specification to meet those requirements. Much like the DVB project, but we focus on a time T, which isn't the availability of a specification, but rather the time when a product is launched in the marketplace. Once the specification is developed, there's quite a substantial amount of work done for the development of what are termed test assertions, which are developed by those that have drafted the specification itself and are used then to specify the test suite further down the line. Critically in HbbTV, we have decided to gate the availability of the published specification on the availability of the test assertions for that specification. So no test assertions, no specification publication. And by holding this essential guillotine over the people that develop the specification, you will be quite surprised how efficient the development of test assertions becomes. So that's a critical element of that HbbTV lifecycle. But then we move to where HbbTV itself takes over from its own members. And HbbTV Association manages a fairly complex workflow for the development, the validation of a test suite. And that test suite is available free of charge to any HbbTV member. And that happens at least 6 months, if not longer, before the availability of an HbbTV piece of equipment that complies to the specification we have developed some 36 months before, or started developing some 36 months before. So as you can see, it's quite a long process, but it's a quite well-defined process, and that defined process means that it's clear to HbbTV members what HbbTV is doing at any given time and where in the life cycle a particular specification is. Because what this also means is that we have the possibility of running multiple cycles at the same time. And so what we do here in this particular situation, you'll see here from this example, that any particular time we could be developing requirements for a specification which itself is nearing the test suite or indeed the market deployment situation. And what we've undertaken in HbbTV is approximately once every year is to recommence the development of a new version of the specification, of the core HbbTV specification. So specification N would then lead to N+1 1 year later, N+2 another year after that. But we recognize that in this particular case, you may not have enough meat in a specification to warrant a new version of the core HbbTV specification. So we might roll requirements into requirements for a subsequent specification. As an example, we've just finalized and published version 2.0.3 of the HbbTV specification. The specification group itself in HbbTV is working on specifying version 2.0.4 of the HbbTV specification, and the requirements group has just commenced requirements capture for version 2.0.5. So it looks like a complicated process, but the idea is with this regular gating, any HbbTV member is able to understand at which point he can introduce his requirements, where he introduces his requirements into the group, and how he might follow the process right from start to finish. Now, DVB is not so sophisticated because, of course, its scope is much wider, but it does have a work plan. And this published work plan is one of the things we introduced a couple of years ago. It's a little complicated, if the truth be known. It's not that easy to read, but it is a publicly available document that stipulates what is going on at any given moment within the DVB organization. And it covers all of the different elements, from the requirements for a specification through to the requirements for its validation and verification, through to the availability of that specification based on the requirements, and the availability of the V&V materials based on the V&V requirements. So, and again, what we're doing is we're moving a DVB project into an organization where completion of the V&V work is seen as a prerequisite for forwarding the associated specification for standardization. So again, similar personalities, similar approach, although the scopes are quite different. So what does HbbTV mean for the DVB project? Because this is something where I'm involved in both organizations, and I need to ask myself, is this all worthwhile? Well, the answer is, of course, yes, otherwise we wouldn't be doing it. So HbbTV has replaced MHP as DVB's hybrid television solution, and representing, if you like, the content providers and the broadcasters, I would say to my members that you would be very silly not to deploy hybrid television solutions as part of your linear services. And therefore, HbbTV is a core element of any DVB, modern DVB proposition. And that's a critical element. It means we need to support both. We, of course, we work in areas of common interest. Some of them we've seen with Peter Lanigan. The reference application for DVB-I is in fact available as an HbbTV op-app. We have similar we have co-developed this targeted advertising solution which Peter Lanigan referred, and as he pointed out, the DVB-I version of this it continues to be developed. And of course, we share the burden of developing tools of common interest in this validation verification space. So in short, HbbTV are similar but different. They have many areas of common interest and common personalities involved. And I would call the relationship a very symbiotic one, fostered by those common members and personalities. So with that, I'd like to say thank you very much to all, and I pass back to Jörn.
Thank you, Peter, for this update on HbbTV and DVB. As we've seen, there are lots of similarities, and we've received a lot of questions from you, so thank you very much. I will close the question function for now because we have more than enough, and I'll ask Thomas in the background to share my screen. Yes, it's already there. So we can get started right away. This is only the first slide with questions that we have. The first two questions actually refer to a bit of the same issue. I'll read that out now. One of the strong points of DVB-T, S, and C is the highly controlled and predictable quality of network delivery because these networks run with DVB-T, S, and C. How can this be achieved with DVB-I? In brackets, IP networks run with different technical protocols. And second question, bit the same, referring to scalability on DVB-I. Is the internet really ready for the scale of broadcast requirements? Who wants to respond?
Maybe I'll start, and then if Peter Lanigan wants to add anything there. I'd say the key proposition of DVB S, C, and T is based on the proposition of a quasi-error-free delivery. And quasi-error-free is quite well defined within the context of DVB, and we've tried to ensure that the linear specifications, that downstream specifications that we have developed, are as robust as possible. It is 100% clear that the internet is designed in a different way, and that we cannot rely on the same level of technical infrastructure. But one of the key propositions of DVB-I moving forward will be how we ensure that a consumer at home has a transparent media experience, which builds together the combination of the flexibility and potentially the higher quality that is available across the internet streams versus his potentially more reliable but less higher quality version of his broadcast stream. And so building together that combination is, if you like, the silver bullet that will ensure that we have this consistent high quality user experience. And there are discussions going on about how we might ensure and manage that transition so that for the consumers who have a TV set, who are perhaps less tech savvy and are not in a position themselves to switch between broadband and broadcast, that can be managed for them in some form or other.
Okay, Peter Lanigan.
Yeah, so Peter gave an excellent answer, actually. Just to mention a couple of slightly more technical aspects to that. The DVB- specification, this supports what's called adaptive streaming, which looks to make the best use of whatever bandwidth you have available, and can also dynamically adjust based on, for example, the level of congestion of your network connection. So we'll always give you the best possible quality given the circumstances. This is not the same, quality of service is a different kind of issue on the internet compared to broadcast, but we have ways to make this work as well as possible. The question of scalability and what happens if we're transmitting the same channel to hundreds, thousands, millions of users, that's a very good question. And I think this is, I'm a TV manufacturer, and this is kind of for network operators to solve, and content delivery networks and the like. They are doing this already to a large degree with using adaptive streaming and finding efficient ways to do that. But this ABR multicast specification we've developed, I think, is potentially very important because that will allow, rather than an operator having to carry one copy of a service to every user, individually to every user, it will allow over any particular network segment that service is only carried once. And this is what multicast lets you do. So that's potentially a huge optimization. And I think it's likely that if we're going to scale to really millions of users, we'll have to look at using these technologies. But DVB-I takes this into account from the start, and this can be done transparently to end devices. So it's something that can be done, can be retrofitted if you like. It can be done by a network operator whilst maintaining service to existing devices.
Right, I'd like to come to the next question. What would prevent an illegal channel to appear through DVB-I as a legitimate TV channel in the channel list?
So this is at the this is a key discussion going on at the moment internally in the DVB project. What's an illegal channel? Okay, you can start there. But what's a legal channel? What's an illegal channel? You can start there. Then you can have a conversation about how you might prevent it, really prevent it appearing on a TV set. These are issues that cause an almost religious debate currently internally in the DVB project. I mean, you need a week-long webinar to even cover some of the topics, but it's a very hot one at the moment.
It's work in progress, let's put it this way, but it's good to address these issues, of course.
I think from a technical perspective, we can solve this. We have all the tools in terms of authenticating lists, making sure that lists come from trusted sources, making sure that services come from trusted sources. It's more the infrastructure you build around that. How do you establish trust? Who can trust, this kind of thing? And that's the questions that are being discussed at the moment. But technically, again, the spec I think supports everything that's needed.
Yes, so I just, of course, Peter's right. The bits are all there. The issue is how do you build on the bits? One of my own personal ones is in MHP. We built a relatively sophisticated mechanism of validating applications. In other words, what would if a rogue application was to be received by a set-top box or a TV set that was running MHP at the time? And crash the TV set or something else. So we built an infrastructure around trying to ensure that that would not happen because the specification called for it. It was never used. Ever.
Okay, look back into the past. Anyway, I'd like to continue with the questions because there's another whole slide of questions that we have lined up. How confident are we that telecom networks will accept or implement DVB ABR multicast, which seems necessary to achieve the DVB-I goals? Now, what's DVB ABR multicast?
Well, this was a specification I referred to that it's the optimization of the multicast optimization for operators, allowing them to carry one service once to large numbers of users.
Yeah, okay.
It's a good question. Again, I don't work for a network operator, so maybe I'm not that well qualified to answer, but to some degree, this is going to be demand-led. I think if users want to access these linear services online, then it's going to be beneficial to operators to implement this stuff, to look at this as a solution. It's not necessarily the only solution. I mean, content delivery networks already can deliver content at very large scale and are doing so at the moment. But linear content is a little bit different, and it can be optimized in a different way. But I think this will be, again, we're putting in place the tools that can be used to do this, and I think there are various ways to help with scalability, and this is one.
So in direct answer to the question, how confident are we? The answer is telecommunications networks rarely do anything because they think it's a good idea. They typically do things because there's a demand for them. And I think, as Peter Lanigan is suggesting, if it is demand-led, then that will facilitate that that introduction. But the tools, again, are there.
And I should also say that telecoms networks did take part in the standards effort in writing the spec for EBR multicast, so they are aware of this and interested.
Yeah, I think that's generally important to know that, of course, both DVB and HbbTV are very much orientating themselves towards the feedback and needs and requirements of the market and market players. And that is reflected then in standardization and in the specifications. A specific question for you, Peter, TP Vision. There is the status of DVB-I being inquired about at TP Vision. Are you already playing concrete implementations?
Okay, so I'm not authorized to make product announcements, unfortunately.
Okay.
We did demonstrate DVB-I. There was a demonstration of DVB-I at IBC in 2019, so 18 months ago now.
Yeah.
And we took part and we showed a prototype DVB-I receiver. We showed this running on an Android TV, on a real product Android TV. That was a prototype implementation. We would have very much liked to contribute to another demo at IBC 2020, but of course that didn't happen. Yeah, I can't make product announcements. This is something we're very interested in. I think for sure if there are services, when services, by and large, TV manufacturers tend to implement things in parallel with services being developed. So I'm very confident that if we see services being deployed, that TV manufacturers, including TP Vision, will implement this. It's something we're clearly interested in and devoted a lot of effort to, and I think it will. If there are services, there will be products. I'm not worried about that.
Yeah, and if I might point out that on the service side, there's a variety of things going on in this space. There's a significant interest in potentially moving to even mandate DVB-I in some markets, and in other markets, Germany is another case of interest. The broadcasters see this as a very useful adjunct to the current suite of technologies. And our publishing services at the moment. So it's the sort of thing where, of course, it's a chicken and egg. There's always the chicken and egg, but once attractive services become available, then it becomes an easier proposition for the vendors to incorporate the appropriate technology.
Yeah, as usual, the consumers are not so much interested in technology. They're interested in features, services, and content. And in the best case, technology is invisible for them. Anyway, next question: is there not an overlap between one side DVB ability to combine IP streams and DVB streams, and on the other side HbbTV? In fact, maybe Peter MacAvock.
For sure, there's some overlap. But the proposition is subtly different, and we see the technologies being largely complementary. Otherwise we wouldn't have gone down this route. But yeah, we see that the technologies is largely complementary. And as we pointed out in the DVB-I proposition at the moment, which is to help validation and verification, which was the quickest way of getting DVB-I technology onto TV sets, was seen as doing it as an HbbTV operator application. So they're rather complementary, I'd say. There is some overlap for sure, but I see them as complementary. This is an area where we've published some documentation to try and explain that.
And you can see the next question being associated with that. Can HbbTV red button apps be used with the DVB-I service? So what happens there? Yes, clear question, clear answer. Okay. Thank you. That brings us to the next slide from your questions. What are the objectives and perks for the market existing services, users, telcos, broadcasters, manufacturers to move towards DVB-I? Would it create a competitive offer rather than complementary to what already exists? I think we touched that already, but maybe a bit more specific.
So if I could point out, I think we're on a journey in this space, and that journey is one where a broadcast network on its own will not be anymore the only access network used for the delivery of services to the consumers. So the service proposition that consumers enjoy today is built on a hybrid model based around DVB and HbbTV. And in the future will be based around DVB, including DVB-I and HbbTV. And we're on that journey, and it's a sliding scale as to the extent to which it's broadband only, but it's not going to be any more broadcast only. And so I think it's one of the key aspects is you need to have all these technology bricks in place, and you need to be able to deliver the high quality services that are consistent. A rich, high-quality service consistent with the linear experience, but you need the personalization, you need the targeted advertising, you need all of these other personalization elements that are consistent with the broadband experience. So it's going to be a mix. It has to be a mix going forward, and it's a sliding scale as to where on that scale you are. So it's not just a perk; it's an essential part.
Yes, and again, it's a reaction to the market development as such. Next question regarding 5G broadcast. Is there any news about client devices that support it? As far as I know, our viewer writes, there are no known user devices that support FEMBS.
So this is an interesting one. We understand that there are devices available which incorporate the 5G broadcast functionality into the standard 5G chipsets, but that's only part of the battle. You have to make the case for the inclusion of all the front-end elements into devices, and you have to make the case for the device vendors to enable such a service. Strip away the word 5G from this, and it looks rather similar to DVB-H, so which didn't work, by the way. So what we needed, and by the way, I spent an awful lot of time promoting it, but it still didn't work.
I spent an awful lot of time writing about it.
Yeah, a lot of time
honestly, it was great fun at the time, but it didn't work. So we need to develop something different in terms of a proposition with the case for 5G broadcast, because the technology's not that hard. Making the business case for it to be included in devices, that's where the problem's going to be.
But it's also maybe interesting to see how DVB-I would be used with 5G broadcast. DVB-I is almost filling a gap that 5G is specifying all the physical layer and the network layer and so on, and we're filling a gap regarding signaling and how you create a service offering to the users there, which 3GPP is not currently covering. So that's I think how looking at how DVB-I will be used for 5G broadcast.
Yes, as far as I hear from the market, the chip manufacturers are open towards 5G integration, 5G broadcast integration in their chipsets, and the first prototypes of receivers being developed at the moment. One from ORS in Austria, ORF subsidiary of public broadcaster ORF in Austria. So the market is evolving here as well. The next question: will DVB-I support the HbbTV service? We addressed that already.
We did.
I think so. Yes.
And then I'm a bit confused. Our viewer says regarding DVB-I over 5G broadcast. Does this mean DVB-I is intended to replace 5G broadcast?
So the short answer is no. It's
yes.
It's a different element. I think the key thing to point out is that a very simplistic way of looking at this is that DVB-I is essentially a way in which a broadcaster or a media company could propose a service to a range of devices. And so the concept of a DVB-I service is something which could then be delivered over any type of broadband network. It could be over a 5G broadcast network. It could be over a fiber broadband network. Doesn't matter. And that's what we're trying to get to. So you develop your service. Sorry, go on, Peter.
As a DVB-I service list can contain services of many different types. So you have an over-the-top service, a DVB- service, a broadcast service. This work is really allowed extending a service DVB-I service list, so it can also refer to 5G broadcast services and other 5G services.
Last questions touching security. Which content protection will be used on DVB-I?
So DVB-I, well, we use DVB- for media transport. This allows you to use I'm sorry, I forget the names. They MPEG common encryption. There's a framework for using content protection with the DVB- services already, and you can use that with DVB-I. So I would expect it's going to be the same content protection systems that are currently used to protect IP services. DVB doesn't choose one. We have a framework that enables you to use many different systems.
Okay, thank you very much. This sums up our questions. Thank you very much, Peter MacAvock, Peter Lanigan, to take the time to be part of this webinar. And we see from the strong number of registered attendants and from the large volume of questions that this has really been an interesting topic today. And I'd like to remind you that, as usual, this webinar has been recorded and will be available as a recording on YouTube very shortly. The presentations will be made available for download as PDF files from the HbbTV website. The links you will receive tomorrow automatically, since you've registered for this webinar, and you will also be reminded of the next webinars that you can see here. You can see the issues being addressed here for the next dates of the webinar series. And of course, the HbbTV Association is open towards suggestions for further topics in this webinar series. And as usual, at the end of this session, there will be a small survey for you where you can rate this webinar so we can improve the webinar series. Thank you very much for being with us today. Thank you, take care, and stay well. See you next time. Bye.